Okay, here we go. Zeros and polynomial functions. We're going to do some problems where it's very straightforward. You've done it before. We're doing some problems where it's complete guessing and checking with some synthetic division. So, finding the zeros. All you do is set the function equal to 0, and then you solve if you can. Such as isolating x immediately. That's the easiest way to do it. Or factoring. If not, quadratic formula. Or if you have 4 terms, then you would just do grouping. Or if you have more than that, then, well, you can't do it. Well, yeah, you can. Well, I'll show you how to do it today. But that's stuff you haven't seen yet. So, first one, set this equal to 0, and you get x to equal. Going fast today. Here we go. This one, next one. Number 2. You can't isolate x, so does that factor? Minus 2, minus 2. So, x equals? Alright, moving on. Okay, next one. Set this one equal to 0. This one factor at all? Yeah. Take out in x. You're going to get x squared plus 9 equals 0. So when I do this, I get x equals 0. And that's the only real root, by the way. That's the only real root. Can we see this? It's just way too yellow. That is like very yellow. Has it been this way the whole time? And no one said anything? That's awesome. That means you really know how fast we have to go. Thank you. Is that better? Yeah. Or should I just zoom in more? It's cold? I can't help you with that. You got a good strategy. You got like a sweater half on. Perfect. Alright, so that's the real root. Does it have any imaginary roots? What if I set this equal to 0? So if I did x squared plus 9 equals 0, don't I get x squared equals negative 9? Plus or minus 3i? These are imaginary roots. I don't know. This one just said find all zeros, so those are imaginary zeros, or imaginary roots. I'm just showing all the roots you can find. It'll be more specific. That is like a very, very vague. It'll be more specific. It'll say like find all real roots. I don't care that it's cold. I actually enjoy the cold. Okay, number 4. Just one factor. No. Yes, it does. How does it factor? X squared minus 4, x squared plus 4. Again, these are equal to 0. Hey, is that factor again? X minus 2, x plus 2. And I still got the x squared plus 4 equals 0. So set each of these equal to 0. I'm going to get x to equal 2. Negative 2. See, x squared plus 4 equals 0. X squared equals negative 4. X equals plus and minus 2i. So these are my reals. These are my imaginaries. Let's focus this a little bit, because it looks like you can't see anything. Is this fine, or we need to make adjustments? Good enough? Good enough. Right? Yeah? Alright. Yeah. Okay. Thank you for the one opinion that I needed. Okay, the rational root test. So this is where we start to talk about like what rational... So imaginary, by the way, is not rational. Imaginary is imaginary. So rational root test. So if you have this long polynomial, so you have like lots and lots and lots of terms, and I said you can't do that. Well, you can now. So if you have this really, really long polynomial, and it tells you to factor it, and you're totally lost, you can actually use synthetic division. You can use guess and check. Okay, and you can also use like a guided guess and check, because you can always just guess and check random numbers. But it's probably best to use numbers that might work. Okay? So here's what the theorem is. It's pretty much you're going to make a list of all factors of P and Q. What is P, you must ask? Well, it's the factors of the constant term. So P refers to the constant, and Q is the leading coefficient. And these are the possible zeros that it can be. It's probably easiest for me to actually do an example than just to sit here and talk about it. Sound good? Let's just do an example, everybody. Here we go. Okay, so this says list all possible zeros. So please don't go through and do the entire problem of solving what the zeros are. It's not asking for that. It's asking for possible zeros. So 8 is my P. And what's the imaginary number in front of this? 1. And that is going to be my Q. So P is going to be all of the possible factors. So what are factors of 8? 1, I'm going to go in order. 2, 4, and 8. What about negative values? Can I just put plus and minus in front of all these and be good? So these are possible values of P. We cool? Okay. What about all possible values of Q? So I could come up with all the so what I have to do is I have to do P over Q. And these would be all my possible ones. Well, luckily Q is just a 1, so it's not that hard to figure out. So what's 1 divided by 1? 1 plus or minus 1. What is 2 divided by 1? 2. 4 divided by 1. 8 divided by 1. Okay, and if I had more numbers down here, I would keep listing, but that's it. These are all my possible values. Sound good so far? Cool, let's move on with our lives. Alright, number 6. What's my P value? I'm just going to say just the 12. That's all I care about, because it can be all plus and minus anyway. And what is my Q value? So what are my possible factors of P going in numerical order? Plus and minus 1. Plus and minus 2. Plus and minus 3. Plus and minus 4. I'm glad someone said 5. Plus and minus 6. Plus and minus 12. Woo! It's got a lot more. And then Q. I always put like a little division sign over it, so it kind of helps me when I have to go to the next phase beyond this. So what are my factors of 2? Alright, so all my P over Q's. We have quite a few here. Alright, so let's do all of these divided by 1. So 1, 2, 3, 4, 6, 12. Are we good so far? Okay. I just listed all of them over 1. Now let's list them all over 2. We will get some repeating numbers. Don't write the repeating numbers. Don't be a sucker. Alright? Just list whatever's new. So now I'm going to divide all of these by 2. So I have 1/2. Do I have that one yet? No, so I have 1/2. What about 2 over 2? I already have that because I have to go to 1. What about 3 over 2? So 3/2. What about 4/2? That's 2. I already have it. What about 6/2? That's 3. I already have it. What about 12/2? I already have it. So how many possible values are there? 1, 2, 3, 4, 5, 6, 7, 8, and then the negative, so there's 16. So if we wanted to factor this number 6, we could try 16 different things. It sounds so fun. Alright, this gives you a little hint about how to find it using Descartes. I'm better than Descartes. I can help you better than this guy, so I'm going to ignore that for right now, okay? Not so worried about it. We're on a time crunch, so I'm going to tell you Meidenbauer's rule of how to do this. You cool with that? Because I can do it better than most. Especially Descartes here. He's been dead for a long time, and I'm still living. Alright. So, I'm just going to cross out this last part. So, just find the rational roots of f of x using the rational root test. So, I need to first come up with my possible roots that I can go ahead and try. So, well, what are they? I have to do my P is 6, and my Q is 1. Am I going too fast? No. Oh, good. I thought I was going very fast. All 3 people that responded, thank you. All the remaining 29 of you are probably going way too fast, but I'm not going to say anything. He's going to yell at me. Good, that's how you should feel. Alright, so the P values are... That was a joke. So 1, 2, 3, 6. We cool? Q values are just going to be 1. So my possible P over Q's are going to be Alright, so I'm going to go ahead and do synthetic division. I always guess 1 first, because it's the easiest one to do. I always guess 1 first. Okay? So, what are my coefficients? I have 1, -1, 1, -3, -6. Yeah, it's definitely not going to work, but we'll go through it. Okay. All I'm doing is, I'm doing synthetic division. Now, what goes in that box? I have 8 choices. I can use +1, I can use -1. I can use +2, I can use -2. I can use +3, I can use -3. I can use +6, I can use -6. At least one of those has to work. Okay? No, just till you find the right one. These numbers right here, those are these coefficients. 1, -1, 1, -3, -6. So no, as you get really good at this, you can probably do this within 3 tries. There's like little tips and hints that I'll give you along the way. So first one, let's just go through with 1s. I know it's not going to work, but let's just do it. So you're going to get 1, 1, 0, 0, 1, 1, -2, -2, -8. Is that remainder a 0? No. So is 1 going to work? No. You want to try another number? Well, we have to, so. You want to try -1? Yeah. Wow, that's pretty dicey, but let's go for it. I usually don't try negatives till last, but. So I'm gonna do like a faint scribble, so like I can see that work. Like as a grader, I'm like, okay, they tried it. Not like I don't want you to ever see this again scribble, but like a faint scribble. So you, the doer, is like, oh, I don't need that anymore. But me, the grader, is like, okay, they tried something. All right. Someone just said -1 doesn't work? Yeah, I didn't think so. So 1, -1, -2, 2, 3, -3, -6. Oh, it did work. Who said it didn't? Wow. I told you it would work. I was just being devil's advocate. Come on. Okay, so we have one of our zeros. One of our zeros is x equals -1. It's awesome. Now, I'm going to keep doing this until I get down to 3 terms. Why would I keep doing it until I get down to 3 terms? Because then I can write it as an x squared and I can factor it or do whatever, because that's where I'm comfortable with it. So am I down to 3 terms? No. So I have to keep trying. Could it be -1 again? It totally could. It could totally have a multiplicity of 2. Do you want to try -1 again? Sure? Okay, whatever. Oh, by the way, why would I not try 1 again? Because it already didn't work. It's not going to work again. So let's try -1 again. Let's go for it. I have no clue what the answer is, by the way. We're just going along for the ride. Here we go. 1, -1, -3, 3, 6, -6, -12. Didn't work. But I got my first clue. From the bottom. Did you know that after you're done doing synthetic division, if there are alternating signs, then we are too low. So there's no number that's going to be less than -1 that works. Okay? So can I try -2? No, that's not going to work. -3, can I try that one? No, that's not going to work. That's a lot of people don't know this trick. This is why my way's better. So if you're alternating signs, you're too low. So let's try another number. So what number do you want to try now? Try 2. And again, I'm starting from these numbers right here. This does work? 1, 2, 0, 0, 3, 6. It worked! So I also have 2 as an answer. So what am I left with now? X squared plus 0x plus 3 equals 0. Does that factor? Has this been off the screen the entire time? Okay, good. That would be kind of like silly if it was off the screen the entire time. So does that factor? Now, actually, when I solve it, what kind of numbers do I get? Imaginary. Are imaginary numbers rational? They are not. Do I care about them? No. So I found the rational zeros. Here they are. Let's try to see how much we have left. All right, number 8. Do you want to try 8 on your own? Give it the old college try. Want me to just do the P and the Q for you and then you try it, or just try it all on your own? All. You're gonna try it all out. All right, go for it. I'll pause the video. All right, what are my possible P over Q values? I'll just skip right to that. What are my possible P over Qs? Who's got them for me? Plus or minus 1. Plus or minus 3. Plus or minus 1/2. Yes, these are all my values because my P's can be plus or minus 1, plus or minus 3. My Q's can be plus or minus 1, plus or minus 2. So these are all my options here. So let's just give me the spoiler. What works? 1. Oh wow, that's pretty cool. So 1 works. So 2, 3, -8, 3. So we're going to get 2, 2, 5, 5, -3, -3, which gives me a 0. Can you just factor it from there? So, okay, this one didn't take too long.
Wait, I kept dividing.
Oh, then, all right, you do your thing, I'll do my thing.
But I have a question.
Yeah.
At the very end, I got 2. That was it. Do I set it? I don't know.
You only got 2. This should be what it is. It should be x equals 1/2 and x equals.
I got those, but then when I was done dividing, the only number I had left at the bottom was 2.
It should be a 0.
It was 2 and then 0.
So it says 2 equals 0. That doesn't make sense. Want me to go through the division here?
Can you please?
Sure. Anything for you. So,
1/2 and -3.
yeah, it's 1/2 and -3. So I already know that these are going to work. So what should happen at the end here? Oh, I know what you're saying now.
The 2.
Right, because when you're done doing your division, obviously when you drop down the last one, it's always going to be a 2. It's always going to be the coefficient. You don't do anything. As long as whenever you reach your last 0, when your second number is the last 0, you're done. But I'll just go through this anyway because... And that worked. And then 3... Or -3, I mean. Yeah, that means you're done at this point.
Okay.
You're just done. Okay, so all my zeros are, rational zeros are. Cool. I'll put those little braces so they look nice and pretty. Alright. Who wants to do this nice long one? Yay. Nobody? Cool. Let's move on. We don't got no time for that. Okay. Conjugate pairs. So, getting back to back into the imaginary stuff, taking a little bit of a twist and turn here, what we're doing here. If you have a 0 that's an imaginary number, the conjugate's also a 0. Did you know that? Also works for if a number is irrational. If it's irrational, if you have an irrational 0, the conjugate's also a 0. So what do I mean by that? Is if you have a plus bi, if that's a 0, then the conjugate a minus bi is also a 0. So let's do number 10. This should take about 15 seconds, if even that. So if I have a 0 of 3 plus 2y, what must another 0 be? Let's move on. Okay, so this is important for this kind of problem right here. Let's find a 4th degree polynomial with real coefficients that has, bless you, -1, -1, and 3i as zeros. Is there a missing 0 here? So we're going to have -1, -1, and then plus and minus 3i. Those are all of my zeros. So let's go ahead and find this polynomial now. So if I have a 0 of -1, what's the factor? This one's also going to be x plus 1. Ooh, what about this one? How'd you know that? It is x squared plus 3. That's pretty good. How'd you know that? You're just a genius? I mean, I don't know. There's like a tiny shortcut. Is any other problem? Do I really care about that? No? Okay. Alright, well, whatever. So, let's see. There's the real math way, or there's like the shortcut way. The guessing and check way.
I just did it because like you did it earlier.
Oh, we did it earlier? Because if it's just an I, it's just really going to be just a plus. It's going to be a squared plus it. So, like, shouldn't this be a 9, actually? Yeah, it should be. So it should be x squared plus 9. It's kind of like guessing and checking. You can go backwards. If you set this equal to 0, you'll get plus or minus 3i. Okay? So this is so if I wanted to find what this polynomial was, I would distribute everything. So I would do x plus 1 times x plus 1, which is x squared plus 2x plus 1. And then I would distribute that all the way through to the x squared plus 9. So I'm going to get x to the 4th plus 9x squared plus 2x to the 3rd plus 18x. So this is my first distribution. This is my second distribution. And then plus x squared plus 9. That was my last distribution. And now just reorganize it. So x to the 4th plus 2x to the 3rd. There's only one of those guys. There is 10x squared plus 18x plus 9. And this is the polynomial. Or just write f of x equals in front of it, so it's a polynomial. Can you see that? Almost done. Almost done. You cool so far? Last part. Oh, you see how this says homework down here? This is what I do. Don't need it. Okay. So for this one right here, write this as the product of linear factors and list all the zeros. So this just means we need to find all the zeros. We have to do that anyway. And then write them all as linear factors. And then just write them next to each other in nice pretty parentheses. So let's go ahead and do that. So this one's going to require some guessing and checking. So what's my P over Q going to be? You said plus and minus 1, plus and minus 2, plus and minus 4, plus and minus 8. Brilliant. How'd you get that? Oh, because P was 8 and Q was 1. Since it's 1, there's no fractions that are going to be involved here. Too fast? Good. So 1, 0, don't forget placeholder for that 4. 1, 0, 1, 2, negative 12, 8. What number do you want to try first? Try 1. I don't know if it's going to work. No, it'll work. Yeah, well, you're too much. Oh, did I say that out loud? Want to try 1 again? One, 1, 2, 2, 4, 4, 8, 8, 0. Want to try it again? Why? Keep trying 1 until it doesn't work. Ready to try 1 again? Can I get my last shortcut, by the way? 1, 1, 3, 3, 7, 7, 15. Didn't work. Here's the last shortcut. See how all of these are positive? How did I write it last time with this? So these are all positive numbers. That means we're too big. So is 2 going to work? Is 4 going to work? Is 8 going to work? No, so those are the 2 shortcuts. If you have alternating signs, you're too little. If you have all positive numbers, you're too big. So let's pick a different number. What do you want to pick?
Negative 8.
Negative? You just want to go right to negative 8?
No, I'm kidding.
Negative 1? Let's go try negative 1. I know what you're saying, because if it's not negative 8, then it has to be a number higher. Well, you might as well do negative 4 then, because you can kill 2 birds with 1 stone. Well, too bad. I'm already doing this. Did this work? And let's just do what she did and quit. Okay, let's try -2. I think -2 works, by the way. So this didn't really work. 1, -2, 0, 0, 4, -8. Hey, it worked! All positive numbers means we're too big. But this one has a remainder of 0, and this one even has a 0 in it, so it doesn't really count. So now I'm left with x squared plus 4. Can I factor that anymore? So what are my zeros? X equals 1 and -2. Write these as linear factors. So what's the factor for 1? X minus 1. How many did we have? We had 2 of them. Then we had x plus 2. And then we had left over an x squared plus 4. These are my product of linear factors. You all understand? Good.